Hello students, now we are going to start the new topic which is the Kirchhoff law of the chapter current electricity. So let's begin this topic, Kirchhoff current law. So firstly, before starting this topic, we just know about the few little bit information about the junction. So consider a road as shown in this diagram. The roads are meeting one another like this in this particular points, as you can see over there. So consider some wires are connection as shown here. This is a meeting point where all the currents are meet at a single point. This is known as junction. So all the wire meeting at a point, this is called a junction. So junction is any point in the circuit where currents can split. Consider a junction. Let I1 be the current coming towards the junction and I2 be the current coming towards the junction. Let I3 be the current going away from the junction and I4 be the current coming towards the junction. So, I5, if they were going away from the junction, then this is the complete structure of the particular scenario. Sign convention for the Kirchhoff's law. As you can see over there, some currents are coming inward towards the junction and some currents are going outward towards the junction. So how we will take the sign convention for that? Incoming current is to be considered as a positive. Outgoing current is to be considered as a negative. You can consider over like that. If the current is a I3, I5, I1 and I4 and I2. These, as you can see over there, there will be some particular directions. So incoming current we are considered as a negative, as a positive, and the outgoing current we are considered as a negative. So from Kirchhoff law, current states that the incoming current is equals to the total outgoing current. That means I1 plus I4 plus I2. As you can see over there, the incoming current will be the I1, I4 and I2. The outgoing current is equals to I3 plus I5. Alternate statement we can say from the Kirchhoff law of current, that is the algebraic sum of all the current at the junction is 0. That means sigma I is equals to 0. There will be, we have two types of a sign convention of the rule of a sigma. Sigma is a form of a summation. And we are taking integration also in the form of a summation. So what is the difference between these two? This is a discrete summation and this is a continuous summation. So for the case of a discrete summation, we are just using the summation over there. For the continuous summation, we are using the integration symbol over there. Hence, from this diagram, we can say that I1 plus I2 plus I5 minus I3 and minus I5 is equals to 0 as per the sign convention which we have taken. So let's start with the MCQ part at the multiple choice question so that we can understand that earlier topic we understood or not. The Kirchhoff law of a junction is in accordance with the law of conservation of charge, current, energy, and both A and B. The correct answer for this question is both A and B. The point where all the rods are meeting is called as a junction. So, at the junction, incoming traffic is equals to outgoing traffic. Let us replace the road by the wires. So, Kirchhoff law of a junction is also called as the conservation of charge, momentum, energy, or angular momentum. So the correct answer for this question is charge. That means Kirchhoff law of a junction is also called as a law of conservation of a charge. Similarly, we have a next topic which is a Kirchhoff's voltage law. So before we begin this topic, let us understand what is an electrical network. It is a combination of a various electrical circuit element and the source of a EMF connected in simple or complicated manner. Kirchhoff voltage law states that the algebraic sum of potential difference of all the component and sources of EMF is equals to 0. That means the summation of IR plus summation of E is equals to 0. To understand this law, let us first understand the rule and conventions needed for this. So procedure of a signed convention for the Kirchhoff's law. To understand this law and its convention for closed mesh, let us understand one example. Assume the direction of a current. For a resistor where current enters the resistor, mark it as positive, and where current leaves the resistor, mark it as a negative. For a cell, take negative sign when you transfers from the positive to negative terminal and take positive sign when you transfers from the negative to positive terminal. Now, the mean of this, that means if we just take the potential difference between the point A and B, so VAB is equals to VB minus VA. Because of this, we can take the value of IR. If we take another cell A to B, so the positive terminal and the negative terminal of the cell is VB minus VA, that is a minus of E. Apply Kirchhoff voltage law in the closed loop where the number of loops is equals to the number of unknown variables. Consider an electric network having two EMF sources E1 and E2 and the 5 resistors R1, R2, R3, R4 and R5 as shown in this diagram. So, due to the source E1, current start flowing in the left direction and let this current be the I1. Due to the source E2, current start flowing in the left direction and let us this current I2. At the junction D, both these current meet and they move at the right. Hence, the current will be I1 plus I2 over there. At the junction C, current I1 and I2, that means I1 plus I2, split into two different parts, that means I1 and I2. Consider R2. Current I1 enter in it from the upward. Hence, we mark as a positive. And the current leaves from the downward direction. Hence, we marked as a negative. Consider R4. Current I2 enters from the downward direction. Hence, we will mark up as a positive. And current leaves it from the upward direction. Hence, we will mark as a negative. Consider R3. Current I1 plus I2 enters in it from the left side. Hence, we marked as a positive. And the current leaves it from the right side. Hence, we will mark as a negative. Consider R1. So, current I1 enters in it from the right side. Hence, we mark as a positive. And the current leaves from it left side. Hence, we marked as a negative. And the current leaves us from the left side. Hence, we will mark as a negative. Consider R5. The current I2 enters in it from the right side. Hence, we will mark as a positive. And the current leaves from it left side. Hence, we will mark as a negative. In this diagram, how many variables you to see? From this diagram, you can see two variables, which is I1 and I2. We consider two loops where we will apply KVL, that means Kirchhoff voltage law. Consider the first loop, that means AB, ADCBA. So the thing which is keep in mind, students, so the thing is when the loop start from A, it should be ends from the A also. Either the point start from A and not ending from the B, that is not a loop. So in the loop ADCBA minus I1 R2, I1 plus I2 R3,
are in the same direction of a current, that's why we have taken negative. I1, R1 again in the same direction of a current, that's why we have taken negative. But in the case of E1, E1 we taken as a positive to negative terminal, and here this will be the opposite direction, that's why we are just taking as a positive. Let us solve this particular equation. We get I1 R2 plus I1 plus I2 R3 plus I1 R1 minus E1 is equals to 0. Second equation we can make after taking the second loop or another loop. Consider the second loop is a D, C, E, F, D. Again, the point is start from a D and end from the D also. And applying KVL to it. So, in the loop D, C, E, F, D, I1 plus I2 are 3 times a negative because the same direction. I2 are 5 again in the same direction. So, we have just put negative sign. E2 again in this opposite direction, so we have it taken as a positive. I2 R4 in the same direction, that's why we have taken negative is equals to 0. We just rearranging this formula and we get this result. I hope you understand the Kirchhoff voltage law and Kirchhoff current law in a very good manner. So till that, for today, this is the topic, and till that, take care everyone. Thank you for watching this video.